Research plays a big role in science, and data collection plays a big role in research. And depending on the science that you're actually studying or the field of science, you can end up working with really large numbers. For example, if you're in the field of astronomy and you're talking about how far apart things are, those are going to be some really large numbers. In fact, we have different units entirely just to describe how large those numbers are. And then if you're a chemist or an atomic physicist, you're going to be working with perhaps some really small numbers if we're trying to calculate masses or use masses of subatomic particles or really high frequency waves. And so how do we deal with numbers and apply them into our formulas that are either really, really big or really, really small? And the answer to that is to put them into something we call scientific notation. And it's really just a different way of writing the same number, just in a way that is practical for science and the formulas that we use to help predict patterns and so on and so forth. Now, one of the things to remember is that when you're converting a digit, right, or a number set into scientific notation, you're not changing the number. All you're doing is re-expressing, right, the way the number is written down. But the number is still the number, and it holds the same meaning and the same value. Another use of scientific notation is to get our really large or really small numbers into significant digits. Let's say we have a value of about 1 million. And we need our answer to give us only 2 significant digits, right? Or it's something like 1.5 million. Well, how do we keep that large number and give the significant digits that is required by the question or the situation at hand? Well, if you take that large number and convert it into scientific notation, you may only actually need to express 2 digits, and at the same time, you won't lose the value of the number or change the value of the number. So scientific notation essentially has 2 uses. One, to kind of condense really long or really small numbers into more usable forms. And second, really, is to serve the purpose of having and maintaining significant digits. But I know all of you watching this video right now is saying, okay, we've learned all the theory. Tell us, please, the numbers and how do we convert things into scientific notation? We're dying to know. Well, I don't want to keep you waiting any longer. Let's start. So when we're talking about scientific notation, what we're really doing is converting large or really small numbers into workable decimals, okay, or decimal numbers. So a couple key rules when we're doing or converting numbers to scientific notation is that if we move a decimal to the right, it's going to be a negative exponent. If we move the decimal to the left, it will be a positive exponent. And the base is always 10. So you'll always have a number or a decimal times 10 to the, and that depends on whether we move the decimal to the right or to the left as to whether that exponent is positive or negative. Let's take a look at a couple of examples and see how this translates. Okay, so let's convert each number to 3 digits using scientific notation. So I have 300,000 for the first one. Now, this one doesn't have a decimal spot. So what we do is if it doesn't have a decimal spot, you assume that there's an invisible decimal at the end. And we're going to move it all the way until we reach the first digit. And by that, I mean this, which is we'll take that decimal, go 1, 2, 3, 4, 5 spots. Now it's in front or behind, depending on how you want to look at it, the first number here. And so we would write this as 3.0 times 10. Remember what we said, the base is always 10, times 10 to the number of spaces that we had to move that decimal. And so we had to move it once, twice, 3, 4, 5. And since we moved it to the left, that's going to be times 10 to the positive 5. And so this number is the same as this number over here, except now we have a kind of a condensed form. And it can be helpful when we're trying to plug these numbers in or larger numbers into a calculator. Now for the next one, we have 0.0036245. Well, now I don't have to pretend that there's an invisible decimal. There's one right over here. So I'm going to take that and move it till the first number, just like I did with the previous one. So that'll be 1, 2, 3. And remember that we want 3 digits. So we're only going to take the first, second, and third digits here. So that'll be 3.62. And then times 10, the base is always 5. And now, because we had to move the decimal to the right, it's going to be to the negative 1, 2, and 3. So when we move to the right, it's negative, and we move to the left, it's positive. And again, this is the same number as this, except we have a much more condensed form. Still trying to convert these numbers to 3-digit responses. Again, the decimal is already present, so I'm going to move it to the right until it's in front of the first number. So that's 1, 2, 3, 4. And so since we want 3 digits, we only want 1, 2, 3. So it'll be 1.61 times 10 to the n. Because I moved it to the right, that is going to be a negative exponent. And we had to move it 1, 2, 3, 4 times. So 10 to the negative 4. Now for this one, there isn't a decimal spot or a decimal placed in this number, so we're going to put it at the very end. Remember, we assume that it's always at the very end if there is no decimal present, and we're going to move it to the left in order to put it in front of the very first digit. So 1, 2, 3, 4, 5, 6, 7. And so this here is going to be 2.1. Now we only want 3 digits. We're going to go 1, 2, and 3. On the third digit here, we have to look to the number beside it to decide, do we keep the number or do we round it up? Because the number beside the 2, or the third digit, which is of interest here, is a 7, we're going to round that to a 3. So 2.13 times 10 to the, and since we moved it to the left, it's going to be a positive exponent. So 1, 2, 3, 4, 5, 6, 7. So times 10 to the 7. What I want you to do is give the next two a try. Pause the video, give these next two a try, and then hopefully it'll all be clear and you can get right away to using these in your questions in chemistry and physics, especially when you're solving.